Okay, hello, this is Dr. James, and today I'm going to talk about the scope. What is it called? The FNIRS1 or something like that. I'm not sure if they're ones or I's. Very cool scope, portable scope, handheld. Claims it has a bandwidth of about 100 megahertz. Looks like it does measure pretty high frequencies. 2 ports, BNC input, battery charged by a USB-C. I think I paid about, I'd have to check, about $100 or something for this guy. Not too bad. Anyway, let's take a look at it. We'll do an unboxing and I'll go through some of the functionality and test it out and see how it works. Very cool, huh? Let's get going. Okay, hello, this is Dr. James, and here we got this. Let's try unboxing this and see how this goes. Inside here. Very cool, huh? There we go. Is that the name? FN1. I can't even read that, it's too fancy. Anyway, let's get the plastic off of this guy. Take a look at what our scope looks like. There, maybe I'll set this down so we can take a look on the inside. Okay, so here's our box. And let's see what we got in here. Here's the product instructions. Product introduction. Okay. Operation instructions. Okay. Well, looks like it's pretty complicated. Come on. Analysis of common problems. Okay. Signal the output to measure. Okay. And I guess that is the end of our manual. Let's see what else we got in there. Got some nice looking probes with clip things on the end. Looks like BNC probes. You can put little color-coded rings around it. Okay. Okay, so 2 probes come with it. And what else we got? Looks like a USB-C charger. Okay. And here's a wall plug adapter for charging it, looks like. Got prongs there. Okay. And let's take a look at our scope here. I forget what I paid for this. Maybe $100 or something like that. Seemed like it was a pretty good deal. Okay. Looks like we have a little handle here that folds out. What is this? 2 scope inputs. Charging port. Let's see how they handle. You can use it to set it up so it can stand all by itself. And what is this? It's the on and off button. Okay. 2 kilohertz signal out, so you can check the workings of the scope. And I guess I don't see any other buttons on this thing. Very cool, huh? And let's see what else is in the box. I think the box has just got styrofoam left in it. Okay, so maybe we'll get our scope charging and we'll do some testing with it. Very cool, huh? Okay, I'm just trying to get our wall plug thing out. Let's take a look at that. There we go. Here's our wall plug adapter. And here's our USB-C cable. I'll just plug that guy into there. And we got some wall sockets down here. Let's get our scope charging. Okay. There's our scope. And there is our plug right there. I'll plug her in. It looks like that red light comes on. Power. Okay. So I'll let this charge for a while, and I'll try turning it on and see how it works. Very cool. Okay, so let's take a look at our scope probes now. Just open these guys up. Open one of them up and take a look inside. Okay. Okay, so here we have a BNC adapter, clip for the ground. So you can take this part off, so it's a probe. It's got a little grabby thing, little hook there you can grab on the stuff. That's always handy. Okay, so there's our cable. Looks like it comes with some kind of adjustment screwdriver, probably for trimming this guy. I'm not sure how that works. Maybe it's to pop off these little circular rings. Maybe that's what it is. Have different colored rings so you can color code your probes, I guess. And here's the user guide. 60 megahertz, 100 megahertz, 250 megahertz. Okay. Frequency compensation. I guess maybe you can change some kind of adjustment on this guy. Looks like a little screw maybe on the probe to frequency compensate it. Okay. And I'm not sure what the bandwidth is on this guy, because this is the manual for all three. What it says on the probe. Let's see anything on the probe. Oh wait. P410. P410. I don't know if you can read that. 100 to 1, 100 megahertz, 2 kilovolts input. Wow. 2 kilovolts input. Very cool. So you could probably use other scope inputs if you wanted to, but this is looks like kind of a high voltage one. 100 megahertz bandwidth. Very cool. I'll have to test that out. Okay, let's take a look here. It's been charging for a while. And it looks like we have a green light on now. Okay, so let's try unhooking the power here. And I believe this red button is the on button. Let's turn her on and see what we got. Looks like we're booting up. Look at that, very cool. 2 traces. And what do we got here across the bottom? We got VPP. Let me set this up so it doesn't have a glare on it. Okay. So it looks like this is a touch screen. The menu here, system settings, picture view, waveform view, USB connect, screen brightness, grid, always trigger 50%, baseline calibration, XY mode display. Okay. Picture view. I don't know what that is. Okay. Looks like our settings are return, select all, select, delete, page down. Okay. Waveform view. Oh, okay, so this must be if you've saved waveforms or pictures, but there's none saved on there. Okay. USB connect. Okay, we'll try to do that later, I guess. Okay. Okay, so here we have a signal generator. This goes up to 10 megahertz. And, let's take our scope here. And I'm just going to plug our probe into channel 1, like so. And, oh, come on. Oh, what? This popped out. Okay, anyway. Let's hook the signal generator to our scope probes here. Okay. So it's a minus to the minus. I'm gonna need some help here. Okay, so we'll take the minus probe, our positive probe, and hook it to the output of the signal generator. And I'll hook the minus probe to the minus probe like so. And wonder if I can, oh yeah, so you can grab these traces and move them down. I'm not seeing anything as I twiddle the output though. I'm gonna have to fiddle with this for a second. Okay, let's take a look here. So it looks like in order to change channel 1, you can click on this guy up here, and it has open. I think that just turns the channel off, makes it an open circuit. FFT, I didn't see the FFT up here when I did that, but I'll have to fiddle with that some more. You can have DC or AC line coupling, and the probe should be set on, see it's a 1x, 10x, this is a 100x probe. Okay, so in order for the measurements to be correct, it has to be set to 100x. And let's try this. Hit control here. You have a V plus or V minus, so you can fiddle that up or down. Okay, so what I found here is that you hit the touch screen here over channel 1. You can turn off the channel, make it an open circuit, or turn it back on. Supposedly there's an FFT, but I'm not seeing that. You can do DC or AC line coupling. And you can set the probe to 1x, 10x, or 100x, and it should be 100x since that's what this probe is. It's a 100x probe. And then if you go over here and hit Control, you can change the sensitivity of the channel. You can bring this guy up, and there is our signal. Okay, and if I fiddle with this guy, it changes the amplitude. And let's see, where is the frequency? Course frequency is down here. So I can change the frequency. Very cool, huh? So the scope seems to be pretty nice so far. Okay. Let me go all the way up to, just on 10 kilohertz. Let's go up to 10 megahertz. And let's see, I'll have to figure out how to change the time. Maybe right there. Okay, I just bring the frequency down a little bit. So I guess this thing here, T, is trigger, and it looks like it's set to channel 2 right now, the trigger. You can do rising, falling. Let's try triggering off at channel 1. Let's see if we can make this thing stable. And I believe this is the trigger point here. We can turn the frequency up. And I still need to figure out how to change the time division. Okay, so it's frequency 2.79 kilohertz. That can't be right. Okay. I'll put out a sine wave. There's a sine wave. There's a triangle wave. Put it back on square wave. Very cool, huh? And this should be, well, that should be around 100 kilohertz right there. And that is not looking so great. It's around 1 megahertz. It's definitely alias there. Okay. Okay, so if we look over on this side over here, this is T cursor, which is time cursor. It looks like you can move the cursors to measure delta time, and it's got the delta time cursor there and the frequency associated with that. You can do the same thing with the vertical cursors, it looks like. Okay. So it has the delta V there. You can change the delta V, the V1 and V2. Okay, I guess it's V1 and V2. I don't see a delta V there. Okay, very cool. And there's the cursor functions there. Let's see what measure is. Looks like we can measure a bunch of different things here. Vmax, Vmin, V average, VPP, peak to peak, frequency, cycles, time, duty. You can do that for both channel 1 and channel 2, it looks like. It looks like those are selected down at the bottom down here. They're displayed down here when you select those. Okay. Looks like you can save a picture or save a waveform by clicking these buttons. Just out of curiosity. Let's try saving a waveform. We'll go into the menu. It'll say View Waveforms. Oh, look. There's a waveform now. Okay. Wow. Okay. And actually, I think we can do stuff with it. View Waveforms. Looks like we can select it. Select all. Delete. Page up, page down. Okay. And it's just got a little thumbnail of what that waveform looks like. Very cool. Okay. Okay, so now that we got a good signal on there, it's on the kilohertz, about 9 kilohertz or so, we can go to channel 1, and we'll click on the on for the FFT, and then we turn that off, and it looks like we have a FFT displayed along the top up here. Very cool, huh? I don't know if I can see that better, but definitely a FFT at the top. Okay. And it goes away when you turn that off. Very cool, huh? Okay, so I had to read the directions a few times. So I guess the screen is divided into the left and right hand side. And it has the time base up here, but the way you change it is you click on either the right or the left hand side to zoom in on the signal. Okay, so that zooms one way. This one zooms out to a faster time base, 50 milliseconds. Okay. Let's see if we can okay, so we will go to a higher frequency now. Oops. Let's zoom in, I guess. 50 milliseconds per division, 10, 5, 2, 1. Okay, so now let's go up higher in frequency here, so we'll see what the limitation of this guy is. 1, okay, 200 microseconds. See, the time base is right there, 200 microseconds. Okay, 150 microseconds, 20, 10, 5 microseconds. Let's go up higher in frequency. Okay. 5 microseconds, 2 microseconds, 1 microsecond, 500 nanoseconds, 250 nanoseconds. Oh. Okay, so that's 50 nanoseconds per division. So let's tune the frequency up even more. Look at that. So we're at, that's about 6 megahertz there. I'll bring this up to, there's 10 megahertz right there. Okay. 25 nanoseconds, 10 nanoseconds. And I think that is the limit. 10 nanoseconds. Okay. Looks like the pulses are kind of rounded a little bit with our 10 megahertz signal going in there. But looks like the waveform is still pretty flat. Response seems to be flat out to this frequency. Okay. Yeah, it's pretty low frequency. Okay. Anyway, very cool. There is 10 megahertz going in there, 10 megahertz square wave. And I'll put it on sine wave. Okay. There's 10 megahertz sine wave. Very cool, huh? Okay, so here's my high frequency RF generator. And I have it hooked up to my new scope here. Let's turn the power onto this thing. And I'm going to put this on the high range, I guess, since we're measuring up to high frequencies. And I don't know if the scope is sensitive enough to see that. I'm going to have to maybe bring the range down here. Oh, you know what? Let's up the amplitude. We'll up the amplitude all the way because I know that the signal generator doesn't put out a very strong signal. And maybe these scope probes are 100 to 1. They're not super sensitive. You know what? Maybe I'll just hook it up directly with a BNC cable. That way I don't have to worry about this scope probe attenuating it 100 times. Okay. Okay, so I have hooked up a BNC directly to the input of this guy. And I have the signal turned all the way down, and I have it at the lowest frequency range, which is 3 kilohertz? Kilohertz range, 3 kilohertz 100 kilohertz. Let me just turn up the dial here a little bit. And it looks like we are able to see a signal on that guy. It seems like it responds a little bit slow though. Okay. And we can turn up the frequency here. And what are we out of range now? Okay, there we go. Okay. There we go. Get that back into range. So we can see changing the frequency here. Come on. Okay. So we've got our signal generator there. Very cool, huh? And so we're just on the kilohertz range. Let me bring it up to, what's that, 1 megahertz to, 1,000 kilohertz to what, 300, let's see, what scale is that on? That's the B scale. So it has A, B. Okay, so that's 3 kilohertz to a megahertz, I guess. So we'll bring it up to a megahertz and test this guy. And I guess we're good up to a megahertz. And this is what? 1 megahertz to 3 megahertz. I'll change the scale on that guy. And it looks like it's becoming a little bit unstable. Let me zoom in on that a little bit more. Okay. And there we go. So that's 3 megahertz. And we'll go up to the next scale setting, 3 to 10. So that's kind of what our other signal generator does, 3 to 10. Or up to 10, I mean. Goes lower than 3. And we'll bring up the signal. And we're starting to get toward the limit of its sampling. Now, see when it starts behaving weird like that? I think it might be getting the high frequencies by oversampling. It may not be an instantaneous bandwidth there. See, it looks like it's doing some kind of weird averaging, probably an oversampling thing where it will sample across and then sample again the points in between and assume it's continuous or something. Or assume it's a cyclical or a repeating function. So I think in this range here, we're about 10 megahertz, that it is not doing an instantaneous sampling, but it is doing some kind of like oversampling or something like that. That's my guess. It's probably like, here, I'll bring the frequency up a little bit more. That is probably, yeah, probably like aliasing. It's getting the high frequency by oversampling it. That is my guess at this point right here. And so that's around 10 megahertz. Okay, and we'll bring the frequency up, or the 3 megahertz I should say. That's 3 to 10, so this is 10 right now. And so we'll sample up a little bit higher. And I'm going to change the frequency band to 10 to 35. Let's bring this back down. Okay, so there's, so we're in the E range right now. So this circle right here, and we're about 10. There's 10, 11, 12, 13, 15, 20, It looks like it starts to dip a little bit here. 30. So I would say practically the bandwidth, because usually they go by the 3 dB point, which is when the amplitude becomes half of the input. Okay, so see, this is an amplitude. Let's put the cursors back on here. Vertical cursors. See, there's our cursors. And so that's at 10 megahertz. 10 megahertz there. And we'll move this dial around to about 35. Okay, I guess it's not quite half. It's still... Let's go up a little bit higher in frequency. We'll go to the 32 to 150, so definitely at this frequency, unless the oscillator's putting out a lot lower power. It is, oh, you know what? Yeah, so I would say that's about the bandwidth, is about 30 megahertz. Let's bump up the signal so we can measure it still, because I think we're at the limit of the scope. So I'm increasing the amplitude on this guy, and we'll slew through the different frequencies. Oh, it looks like it's going back up again. It has another resonance there or something. Okay, so, and it looks like it is dead right there, which is about 130 megahertz. It's really not locking onto that, but a little bit lower, so about 125 megahertz or so. Looks like it's still picking up some kind of signal. So I guess not such a bad scope. It's got pretty good bandwidth, I guess, depending on how you define the bandwidth. Very cool though, huh? Here, I'll take a look at that. That's screaming right there. Was that around 60, 50 some, 58 megahertz maybe? Okay. Very cool. Okay. Anyway. Okay, so here we have our computer and our scope, and let's see if we can transfer data off of this thing. Plug it into the USB up here. Turn it on. Okay. And let me pull out that little stand in the back. Okay, so let's take a look and see if our computer recognizes this. Now I'm running Linux. And I'm not seeing it. Oh, okay, well maybe let's try this. Menu, USB connect. Turn this on. Okay, oh look at that. A drive volume appeared. And it looks like we have one waveform here. I'm not sure what format that is. I wonder if I can change the format, because .wave is not particularly useful. It looks like there is a waveform that you can copy off of this though. Okay. Maybe I could see if I could, okay, I'll turn this off and maybe save a picture. How about that? Save pic. Menu. get my thing locked up. Let's unplug this. Let's just save a picture here. Okay, if we go into the menu, view pictures. So there's a picture I just saved. I'll hook this back up to the USB. Up here. Okay. And let's see if we can connect to this guy. Okay, it wasn't plugged in all the way. There we go. Open with files. Okay, there's a bitmap. Okay, so there's a bitmap that is saved. Oh, that's kind of weird. Saved like right in the middle, chopped it in the weird spot. Anyway, I could probably reconstruct that with Photoshop or something, but that's not exactly what I'd want to save. Oh, maybe it saved it as it was doing something transient, I don't know. So, anyway, it looks like you can pull across the waveforms and the pictures. Although it's, I'd rather have a CSV. Let me see if you can save CSV. That'd be a lot nicer if you can save comma-separated variables, because I don't know what format .wave is in. Okay. Oh, this thing won't eject. Eject. Okay. Okay, so I figured I'd just try to open that with a text editor to see what was in there, and it looks like it has all sorts of binary type characters, and so I don't know how to translate this format. Current local UF8. Anyway, this is a local text editor on Linux. It's not necessarily a hex editor. Maybe I need to open in a hex editor and try to make heads or tail this thing. But definitely a lot of hex characters. Anyway, I don't know if you can put it into comma-separated variables. I'm going to try to do some research on this a little bit and see. Okay. Kill that. Okay, so it looks like someone else concurs. There's no CSV data available, but looks like maybe some people are hacking these scopes and putting different firmware on it. I'll have to look into that, I guess, but as of right now, it looks like there's no CSV data available. It's some kind of binary format. Maybe you can figure out a way to extract that and get something useful out of it. I don't know. What a pain, huh? Anyway, for the price, it's not too bad of a scope. Handheld, portable, saves pictures and data. Unfortunately, the data is in some kind of waveform, binary format, which is about completely unusable unless you can figure out how to convert that to something. But it's a pretty cool scope for doing things on the go. Pretty high bandwidth. I'll be looking into this some more, see if I can somehow figure out how to make that data useful. Or was some people talking about maybe putting different firmware on it. That might be possible too. Anyway, I hope you enjoyed the video, and this is Dr. Janes, and thanks for watching.